Partial fractions decompose into partial fractions. Let's say we're given this rational expression and it wants us to decompose into partial fractions. How do you do that? First, you need to factor the denominator. Once you factor out the denominator, you assign a letter for each of the factor that you factor out. For instance, the denominator, the x squared minus 4, it can be factored out further by the difference of square. Let's say x squared minus 4. There's a formula, a squared minus b squared can be factored out into a plus b times a minus b. It's called the difference of square. Make sure you put the plus first and the minus first because the formula says that in order. So x squared minus 4 can be factored out into x plus 2 times x minus 2. Make sure you put the plus first and the minus second because the difference of square says a plus b times a minus b. Once you have the denominator factored out, it's time to assign a letter for each of the factor that you factor out. Okay, so the factor form for the given rational expression will be like this. So the next thing is to assign a letter for x plus 2. Let's assign a for that. A divided by x plus 2. As the x minus 2, I will assign a b for it. Make sure you put a plus right here. It's always going to be plus, plus. As for the c, the x plus 1 will be assigned to it. Okay, right here is very important. The x plus 2 times x minus 2 is very important for the a because the difference of square says a plus b times a minus b. So as for the x squared minus 4, it has to be x plus 2 times x minus 2. It's not going to be x minus 2 times x plus 2. So you have to make sure you put x plus 2 for the a and x minus 2 for the b. Because if you don't, when you try to solve this problem, like if you put x minus 2 for the a right here, when you try to solve the problem, it's not gonna go very smoothly. So make sure you put x plus 2 according to the difference of a square formula. So once you have that, you need to find a common denominator and divide both sides of the equation to get a linear equation. So the common denominator will be x plus 2, x minus 2, and x plus 1. You put a bracket on the left hand side and the bracket on the right hand side. For the left hand side, the common denominator will be cancelled out. So you're left with the 3x squared minus 11x minus 26. As for the a, the x plus 2 will cancel out with the x plus 2. So you're left with a times x minus 2 times x plus 1. And copy down the plus. As for the b, the x minus 2 will cancel with this common denominator of x minus 2. So you're left with b times x plus 2 times x plus 1. As for the c, it will be this expression. So once you have the linear equation, your next procedure is to plug in a number for a, b, or c that will turn it into a 0. So let's say if I let x equals to 2, then the a right here will become 0. The same thing as for the c. The c will become 0. Because 2 minus 2 is 0. 0 times a and times x plus 1 will be 0. So I let x equals to 2 and I plug it to the left hand side because if you plug it on the right hand side, you need to also plug it onto the left hand side, and I will get this number right here. So for the A, it will become 0. For the B, it will become, see, 2 plus 2 right here becomes 4. 4 times 3 times B will be 12B. As for the C, it will be 0, because 2 minus 2 is 0. 0 times whatever expressions will be 0. So once I get all the number right here, I solve for B. The B will be -3. Okay, so the next thing is to solve for another number, another letter, I mean. It could be A or C, but first you need to think of a number that will turn one of them into 0. So I write the original equation again, and this time I let x equals to -1, because if I plug it into the x right here, it will become 0. So I also need to plug it on the left hand side and solve for it. So the A will become 0, the B will become 0, because -1, plug it into +1, it will be 0. 0 times whatever expressions, it would be 0. For the C, it will be -3. And to solve for the C, isolate the C by dividing by -3, and the C will become 4. Once you get that, then the other procedure is also to think of a number that will make one of the expressions equals to 0. So I let x equals to -2 and plug it into the original linear equation. For the B, I will get 0. For the C, I will get 0. And for the A, I will get 2. So the A will be 2, the B will be -3, and the C will be 4. Once I get that, I put it back into the original expression right here. This is the partial fractions. So I put the A down here, and the B, the -3 for the B, and the 4 for the C. So the final answer will be like this.